हेलो एवरीवन, ये जो चैप्टर है क्लास 12 चैप्टर नंबर 8 इलेक्ट्रोमैग्नेटिक वेव। टॉपिक 8.1 मैक्सवेल डिस्प्लेसमेंट करंट। डिस्प्लेसमेंट करंट इज दैट करंट which comes into existence in addition to the conduction current whenever the electric field and hence the electric flux change with time. id equal to epsilon naught d phi e upon dt. Importance Important properties of displacement current. First, displacement current exists whenever there is a change of electric flux. Unlike conduction current, it does not exist under steady condition. It is not a current, it only adds to current density. In Ampere's circular law, as it produces magnetic field, so it is called a current. Third, the magnitude of displacement current is equal to the rate of displacement of charge from one capacitor plate to the other. Fourth, together with the conduction current, displacement current satisfy the property of continuity. Topic 8.2 Maxwell's equation. The four basic equations can be stated as follow. Gauss law of electrostatic. This law states that the electric flux through a closed surface S is 1 upon epsilon naught time the total charge Q enclosed by the surface S. Cyclic integration of EDS equal to Q upon epsilon naught. Second, Gauss law of magnetism. According to this law, the magnetic flux through any closed surface is always zero. Cyclic integration BDS equal to 0. Third, Faraday law of electromagnetic induction. This law tells that a changing magnetic field induces an electric field. According to this law, the induced EMF set up in a closed circuit C is equal to rate of change magnitude flux linked with the closed surface circuit. Cyclic integration EDL equal to minus d phi by B upon dt or EMF equal to minus d by dt whole bracket cyclic integration BDS. Fourth, modified Ampere circular law. This law this law states that the line integral of the magnetic field around any closed circuit is equal to the mu naught times the total current, the sum of conduction and displacement current trading the closed circuit. Cyclic integration of BDL equal to mu naught I conduction current plus ID displacement current equal to mu naught IC plus epsilon naught d phi e upon dt. This law implies that fact that only a conduction current but a displacement current. Topic 8.3 Maxwell's prediction of electromagnetic waves. An electromagnetic wave is a wave radiated by an accelerated charge and which propagates through space or as coupled electric and magnetic fields oscillating perpendicular or to each other and to the direction of propagation of the wave. Topic 8.4 Transverse nature of electromagnetic wave. In an electromagnetic wave, both the electric and magnetic fields are perpendicular to the direction of propagation, that is, the electromagnetic waves are transverse in nature. Topic 8.5 Energy density. Energy density of an EMF electromagnetic wave is the energy in unit volume of a space through which the wave travels. Intensity. The energy crossing per unit area per unit time in a direction perpendicular to the direction of propagation is called intensity of the wave. Momentum of electromagnetic wave. An electromagnetic wave transport linear momentum as it travels through space. If an electromagnetic wave transfers a total energy u to a surface in time t, when the total linear momentum delivered to the surface is p equal to mu naught upon c. Pressure exerted by an electromagnetic wave. When an electromagnetic wave falls on a surface, if exerted pressure on the surface, this pressure is called radiation pressure. The radiation pressure for electromagnetic wave of intensity I is given by PR, pressure equal to I upon C. Topic 8.6 Properties of electromagnetic wave are. Pehli property, the electromagnetic waves are produced by accelerated charge and do not require any material medium for their propagation. दूसरी, the direction of oscillation of E and B field are perpendicular to each other as well as perpendicular to the direction of propagation of the wave. So the electromagnetic waves are transfer in nature. तीसरी, the oscillation of E and B field are in the same phase. Fourth, all the electromagnetic waves travel in a free space with same speed c equal to 1 upon mu naught epsilon naught equal to 3 into 10 की power 8 meter per second. Fifth, the amplitude ratio of electric and magnetic field is E naught upon B naught equal to C 1 upon mu naught 4 mu naught I naught epsilon naught. 6. Electromagnetic waves transport linear momentum as they travel through space. P equal to U upon C. 7. Electromagnetic waves are not deflected by electric and magnetic field. Topic 8.7 Electromagnetic spectrum. The orderly distribution of the electromagnetic waves in accordance with their wavelength or frequency into a distinct group having widely differing properties is called electromagnetic spectrum. First, radio waves. These are the electromagnetic wave of longest wavelength and minimum frequency used in radio and television communication system. In radio astronomy. Second, microwaves. They are the electromagnetic waves having wavelength next smaller to the radio waves. Used in radar system of aircraft navigation. In long distance communication system via geostationary satellite. Geostationary satellite. In microwaves ovens. Third, infrared waves. These radiations lie close to the low frequency or long wavelength of the visible spectrum. Infrared waves produce heating effect, so they also known as heat waves or thermal radiation. Used in the remote control of a television or VCR, the keypad of which contains a small infrared transmitter. In greenhouse to keep the plants warm. In a reading the secret writing on the ancient walls. Fourth, visible light. It is a very small part of the electromagnetic spectrum towards which The human retina is sensitive. The visible light emitted or the reflected from bodies around us given information about the world. Use it provide us the information of world around us. It can cause chemical reaction. Fifth, ultraviolet light. This region of electromagnetic spectrum has wavelength just shorter than visible light and can be detected just beyond the violet end of the solar spectrum. Use in food preservation, in the study of invisible writing, forged documents and the fingerprint, in the study of molecular structure. 6. X-rays. These electromagnetic waves have wavelength just shorter than ultraviolet rays, as X-ray can pass through many forms of matter, so they have many useful medical and industrial applications. Used in a medical diagnosis because X-ray can pass through flesh but not through bones. In the study of crystals structure, because X-ray can be reflected and diffracted by crystals. In engineering for detecting the faults, cracks, faults and holes in the finished metal product. In radiotherapy to cure ultra-cable skin decreases and the malignant growths. 7th, gamma rays. These are the electromagnetic radiation of highest frequency range and lowest wavelength range. These are the most penetrating electromagnetic waves used in radiotherapy for the treatment of malignant tumors, in the manufacture of polyethylene from ethylene, to preserve food stuff for a long time because soft gamma rays can kill microorganisms. Topic 8.8. Earth atmosphere. The thick envelope of air that surrounds the earth is called earth atmosphere. Troposphere. This layer extends to a height of 12 km from the earth's surface. Its upper boundary is called tropopause. Tropopause. Stratosphere. This layer extends from 12 km to a 50 km and its upper boundary is called stratopause. Mesosphere. Mesosphere. This layer extends from 50 km to 80 km. Its upper boundary is called mesopause. Ionosphere. This layer extends from 80 km to 400 km. Its temperature increases with height from 180 km to 700 km. The ionopause is mostly composed of electrons and positive ions. This ionization is caused by ultraviolet radiation and X-ray coming from sun. The lower portion of the ionosphere, extending from 80 km to 90 km, is called thermosphere. थैंक यू. ये जो चैप्टर है यहीं एंड होता है. नेक्स्ट चैप्टर विल स्टार्ट लेट्स सून.